So again, today we're going to talk about vertical angles, supplementary angles, complementary angles. We're going to talk about a couple theorems. There's actually a lot in here. I'm sorry you're going to do a lot of writing. I'll pause so you have time. This is the definition of vertical angles, and it's not what you'll find in the book. The book's definition I find to be confusing. Okay? It talks about opposite rays forming lines. Okay? And to me, my experience with students is they get confused and you break down the definition of an angle and use that to be the definition of vertical angles. And so I just like to think about it the way it looks to me. It looks to me like two lines are intersecting there, doesn't it? And so vertical angles are the opposite angles that are formed when those two lines intersect. So the two blue angles, 3 and 4, are vertical angles, and 1 and 2, the two black angles, are vertical angles. So my definition of vertical angles is the opposite angles that are formed when two lines intersect. So, to repeat what I just said when I wasn't recording, the vertical angles theorem tells us what's special about vertical angles. The definition simply tells us what it looks like. The vertical angles theorem tells us that vertical angles are congruent. All vertical angles are congruent. All of them. Okay? All vertical angles are congruent. And so if I look at this picture, what's the measure of angle 1? What is it?
110 degrees.
110 degrees. Why?
Because it's a vertical angle, the one.
Because it's a vertical angle with this angle, right? And since the vertical angle theorem says that all vertical angles are congruent, that means that these two angles have to be congruent. Have to be the same measure. So the measure, notice how we write it, the measure of angle 1 is equal to 110 degrees. Okay? Measure of angle 1 is equal to 110 degrees. If we use a number and use an equal sign, we need to say, put that m in front of it to show measure of the angle. Alright? But we want you to try to be fussy on that. Pretend that you care that there's a proper and an improper way of writing it, okay? I think that the more you write things properly, the less confused you'll be in the long run of what we're doing. Okay? When you recognize there's a difference, there's a right and a wrong way, and you write it the correct way each time, I think you'll have less mistakes later. And you'll score a lot better in your quizzes and tests. Okay? Any questions on the vertical angles theorem? They might not get written yet. Okay, moving on then. Have a couple pictures here, two different angles. We're going to talk about complementary and adjacent. Move up just a little bit so you can get the rest of adjacent, and then pause. Okay. Complementary angles, two angles that add up to 90 degrees. Okay? This symbol right here, most of you look at that and think, oh, that means 90 degrees. It doesn't actually. Let's put that away. Actually, what it means is perpendicular. That symbol means perpendicular. Now, what does perpendicular mean? It means two lines that form a 90-degree angle. So yes, it does mean 90, but the symbol itself really means perpendicular. Okay? And so that symbol means perpendicular, and then that means that this angle's 90 degrees. So these two angles, angle ABD and angle DBC, add up to that 90-degree angle. Remember yesterday we learned the angle addition postulate? This angle and this angle add up to the big angle. The big angle is 90 degrees, so that makes those two smaller angles complementary. Now, complementary angles don't always have to be hooked together like these two. It can be just two totally separate angles that add up to 90 degrees. Complementary doesn't mean that they have to be any specific picture. It only means they add up to 90 degrees. Now, if they're adjacent angles, that means that they share a common side and they share the vertex. So looking again at these two angles, ABD and angle DBC, they share this vertex, point B is the vertex, and they share this common side. Okay? Now, non-overlapping means they don't share any interior points. For example, sometimes I might look at this angle, the green one, okay, and this angle, the blue one, and I might think, okay, they shared this side and they shared this vertex. But also, in the blue angle, this one here, it has all of these interior points. And in the red angle, it had all of these interior points. And so if you look at it that way, you realize that there's a lot of red and blue lines crossing there, aren't there? Okay, and so that means that those two angles overlap. So angle ABD, let me try again. Sorry, I misspoke. Angle ABC and angle DBC are not adjacent angles, even though they share second array BC and vertex B. They're not adjacent because of this overlap here. Okay? So that's why we say non-overlapping. They can't share any common points. But they have to share a common side, and they have to share the vertex. Okay? And this is just what I was just talking about. You can choose to copy this down or not. If you fully understood what I was saying, then you're okay. Okay? In this case, I'm going to walk through it anyway. In this case here, we have angle ABD and angle DBC, or CBD, mean the same thing. They're adjacent. They share this ray, and they share this vertex. But they don't have any overlapping parts. In this picture here, they're not adjacent. For a lot of reasons. One, they've got some overlapping parts in here. Two, they don't share a common side. Angle ABD, this one, and angle FBC, this one, they don't share a common side. All they share is the vertex. Okay? In this picture, angle ABD and angle ABC, ABC and ABD are not adjacent, even though they share this side and they share this vertex. They have all this overlapping parts in here. Now, what I'm saying right here is that just because the angles I've already identified are not adjacent doesn't mean that there aren't some adjacent angles that exist in these two pictures. Angle ABD, this angle, and angle DBC, this angle, are adjacent. No interior parts. They share this common side. They share this vertex. Okay? And same thing up here, angle ABD and angle DBC are adjacent. Okay? We could even say angle ABF and angle FBD are adjacent. Or angle ABF and ABC are adjacent. We can say there's lots of different adjacent angles in there, but not all of them are going to be adjacent. Okay? So do you have any questions on what it means to be adjacent? When we're talking about this in the upcoming days, please try to use the terms adjacent, complementary, supplementary, which we haven't quite done yet. Vertical angle, okay? I'm going to try to get you to use those words because just like in Spanish, if you never practice saying the Spanish words, then you won't be very good at Spanish. And the same thing in here. If you don't practice using the proper vocabulary, the class gets a lot harder. Okay? moving on. Here's an example. Angle 2 is twice as big as its complement. Find both angles. Okay? Angle 2 is twice as big as its complement. So what angle is its complement? Sorry, I missed it. I should have had this in here. To say those are perpendicular rays making their 90-degree angle. So what two angles here are complementary?
2 and 1.
Angle 2 and angle 1. Okay? So angle 2 is twice as big as its complement. So what is its complement? What is angle 2's complement?
Angle 1.
Angle 1. So we're saying angle 2 is twice as big as angle 1. Maybe I should have done that the other way. Think about it this way. Angle 2 is twice as big as angle 1. Okay. Do we know how big angle 1 is?
No, we
So
don't.
what do we do in math when we don't know something?
Use variables.
We use a variable. So let's call it what?
X.
X. So if angle 2 is twice as big as x, how big is angle 2?
2x.
Yeah, 2x, right? Angle 2 is 2x. Now, because I called this a complement, that means these are what kind of angles? Don't be shy, don't be worried to be wrong. Another trick that if you can master that in class, you'll be way better in every class.
Complementary.
They're complementary angles. What do we say the definition of complementary angles are? Someone other than Hunter, he's giving way too many answers.
Two angles
Emily?
that add up.
Good job, Brian.
Two angles that add up to 90. What are our two angles?
X and
2x plus x then are going to equal 90. So 2x plus x is how many x's? I have 2 x's here and 1 x here, right? That's 3x equals 90. And so what do I do next? Divide by 3, so x is equal to 30. Now they want me to find both angles. Which angle did I just find?
1.
Angle 1. So I would say measure of angle 1 equals that. Measure of angle 2 then is equal to 2x, which is equal to 60 degrees. Now, there's a nice way to check these. What did we start out by saying these two angles had to do?
Add up to 90.
Add up to 90. Do they?
Yes.
30 plus 60 is 90. That's a quick check to make sure that you did it correctly, is you actually do what you said they should do. You start out by saying they should add up to 90, so let's double check when we're all done. Do they add up to 90? If they do, odds are really good that we have no mistakes. Okay? Odds are really good we have no mistakes. Now, you haven't really taken the test for me yet, so let me take just a second to talk about that. I could see someone setting this up and being a little bit unsure that they had it right. I have no trouble with you asking me questions on tests. I may not be able to give you the answer without, let me try it again. I may not be able to give you help without giving you the answer, so I may not help you the way you want to be helped. So if you ask me the right questions, I will answer all of them. Okay? If you ask me, am I setting this up right, I have no trouble saying, yes, you set that up correctly. Or saying no. Now, I may not expand on my no and tell you what you did wrong, but I may ask you more questions. Okay? The more you can tell me that shows to me, yeah, you've been working on it, and you know some things, and maybe you're a little bit confused, the more I'm going to be willing to want to help direct you in the right direction. Okay? If you come up and say, I don't know how to do this, I'm going to say that's too bad, because this is where I find out what you know. Okay? So keep in mind, there's right questions to ask on the test and wrong ones. If you're asking me to tell you what the answer is, you need to know right now I'm not going to answer that question. If you're asking me if I'm doing it correctly, I will answer yes or no. I might say, oh man, that is so close. You've got just one little thing wrong. Okay? Which means don't erase the whole thing. Okay? Start telling me what you know about it. And I might say, well, did you do that? Sometimes kids will tell me the right stuff. And I'll say, but did you do that? And you go back and look, and you're like, no, I didn't. And you fix it. Yeah. There will be some multiple choice and there will be some that are not. The new SAT is like 75% multiple choice and 25% student response. And so the math department has decided that we're going to try to model that on all of our unit tests. Okay? Especially on our big tests, but not necessarily all on our. But anyway, that's what I'm going to try to do. Okay? All right, moving on. Complementary angles. Oh, I'm sorry, I read that wrong. Thank you. Supplementary angles. We just did complementary angles. Supplementary angles. Two angles that add up to 180. I'll give you time to copy that down. Okay. Supplementary angles, just like complementary angles, does not matter if they're adjacent or non-adjacent or whatever. All that matters is they do what? Add up to 180. So if they talk about supplements, they're talking about two angles that add up to 180. Okay? An example, angle 1 and angle 2 are supplementary, and angle 2 is 20 more than 3 times angle 1. Find both angles. Now let me pause while you copy that. Some of you will look at this and say, I don't even know where to begin. Well, my suggestion to that person would be always draw a picture. Since they're supplementary, that means, whoa, sorry. Since they're supplementary, that means they have to do what?
Add up to 180.
Add up to 180. A straight angle, A, B, C, that's a straight angle, is 180 degrees. So if I want to be sure that they add up to 180, I'm going to start out with a line, what we call a straight angle, and I'm going to put another ray on there. I can mark that D if I want. It really doesn't matter. I'm going to label angle 1 and angle 2. Now, I want to go the other way. Anybody want to say why I want to go the other way?
Because angle 2 is way bigger.
Yeah, if we read this, it says 1 and 2 are supplementary, and it says angle 2 is 20 more than 3 times angle 1. So that means angle 1 is my smaller angle, and angle 2 is my bigger angle. So I'm going to change my picture to match my information a little bit. Okay? So we know 2 is the bigger angle. So how big is angle 1?
It's X.
Yeah, we don't know, do we? And if we don't know how big it is, we give it a variable. Now you might say, well, we don't know what 2 is either. We should give it a variable. We could, but if we look at the picture, or look at the information, aren't they describing angle 2 in terms of angle 1? They're talking about the measure of angle 2 being compared to how big it is next to angle 1, right? So angle 1 is the angle they're referring it to. So let's call this x. And let's talk about how to write the expression for angle 2. 20 more than means what?
Plus 20.
Plus 20. Okay? 20 more than means plus 20. More than what? Does it say more than 3?
3 times 1.
3 times 1. How big is 1?
X.
How do I show 3 times x?
3x.
3x. So we want to show 3x and then do what with it?
Add 20.
Yes, 20 more than that, so I add 20. Some of you might say, well, can I write 20 plus 3x? Yes, you can. Especially since it's a plus sign. Usually more than means that we put the plus 20 at the end, but it's not wrong if you said 20 plus 3x. Now what's true about these two angles?
They add up to 180.
They add up to 180. Okay, Hunter, you need to slow down so that other people have a chance, okay? I love the fact you're getting it. I want others to have a chance to think about it before they hear the answer. Okay? Thank you. I like to have open atmosphere where you just respond, but don't be offended if I do to you what I just did to Hunter, because I want everybody to have a chance to respond, and he's getting this, and that's awesome for him. I'll make sure we're all getting it. Do we have any like terms here? 3x and x, so that's what? 4x plus 20 equals 180. Oh, by the way, you're not in Algebra 1 anymore, so I'm not expecting you to show me every tedious little step. How do you solve an equation? I expect you've learned that. Now, if you haven't learned that very well and you need to show the steps or you need help, by all means, let me know so that I can help you. And maybe we can master that now. Okay? So what do I do next?
Minus 20.
Subtract 20. So 4x is going to equal 160. What do we do next? Divide by 4. So x is equal to 40. 16 divided 4 is 4, right? So 160 means there'd be a 0 at the end of that. All right? So x is which angle?
Angle 1.
Measure angle 1. What did they ask for?
Both.
Find both angles. Have I done that yet? So how do I find angle 2?
Times 40 by 3.
Measure angle 2 is equal to 3x plus 20, right? So what's 3 times 40? 120. And if I add 20 to it, I get
140.
140. What did we say these two angles were? Yeah, I struggle with that. So many kids say it that way. To me, it's confusing if you say equals 180, because to me it sounds like you're saying both angles are equal to 180. What you mean by that, and I know you mean it, but you're not saying it quite right, is you're saying they add up to 180, right? Or they have a sum of 180. Sum means add up to. If you can help me work on that, I'll try to help ask the questions I really mean, not the ones that I'm saying. So what do these two add up to? 180. So that's a quick check that I probably have it right. Okay? Anybody not finished? Couple things that we need to make sure we understand. We've had some postulates and theorems already. We've not officially told you the difference between a postulate and a theorem, so we had to throw that in here today. Then we have congruent supplements theorem and a congruent complements theorem. Postulate is a statement accepted to be fact, meaning we don't try to prove it, we just accept it's fact. A theorem is a statement that we can prove to be fact. And I'm going to slide this up just a tiny bit so you can see that last word. I see when I converted this, I lost the symbol for angles here. It says if two angles are supplements of the same angle or of congruent angles, then they are congruent. That's what the congruent supplements theorem says. So this is my angle symbol. Well, angle symbol, apostrophe. In case you can't read my writing, it says measure of angle 1 plus measure angle 2 equals 180. This one says measure angle 2 plus measure angle 3 equals 180. In just a second we'll do a proof so you can copy that down. All right, let's get going on this, please, so we can get finished. I by no means expect that you'll be able to write a proof when we're done here. No way do I expect that. So if I never show you proofs, you'll never learn how to write proofs. So I'm going to, from time to time, when they're not super involved, super complicated proofs, I'm going to take class time to actually show you a proof. I personally prefer to use a 2-column form proof, because to me, it seems to organize my information in a much neater way, and it's easier for me to think through the process. A 2-column proof, we would write our statements here, in this column, and we'd write our justifications in this column. Some people might call these the reasons. I would have no trouble if you labeled that reasons, statements and reasons. The reasons means the reasons I know that it's true. The justification I have to support why it's true. Okay? So in this statement, I would write measure, my first step would be measure of angle 1 plus measure of angle 2 equals 180. And the measure of angle 2 plus measure of angle 3 equals 180. And I would ask you this, how did I know that was true? Yeah,
Because it says so.
it says so. They gave me that information right there on the board, didn't they? So my only reason I know that's true is because it was given to me. Always they will give you some information, and I always recommend just write it all down right away. I adhere to the concept that if you get started, you can get done. If you never get started, you'll never get done. I know when I was in school and I had to write papers, I would procrastinate and procrastinate and procrastinate, and I'd have to get started. Even today, I have to prepare for things, and sometimes I'm lost at where to begin. Finally, I just start. And I might write gibberish to begin with, but I get started. If I get started, I can get done. And so my philosophy here is, if I get started on this, by writing the given down, then I have a chance to think through what's going on and I can move on. Okay? Step 2. Does this statement say that these two equal 180 and these two equal 180?
Yeah.
So that means both of those pairs add up to 180, right? They're equal to the same number, aren't they?
Yep.
If A equals B and B equals C, then does A equal C?
Yeah.
Who did I use in here? Did I say if Emily has the same amount of money as Jeff and Jeff has the same amount of money as Rebecca, then Emily has the same amount of money as Rebecca? Didn't I say that?
Something like that.
So if this is equal to 180 and 180 is equal to this, then that means these two must be what? Equal to each other. So I'm going to say measure of angle 1 plus measure of angle 2 is equal to measure of angle 2 plus measure of angle 3. Does anybody remember that T word? Transitive property. Good. Transitive property. You know, one of those things that I said is going to be really important?
Yeah.
Transitive property. If you're linking three things together, you have to consider you're talking transitive property. And this may look like 4, but it's not really. This is 1, this is 2, this is 2, this is 3. So the next step. Now we have an equation, don't we? It's kind of a confusing looking equation, but isn't it an equation? Could I call measure angle 1 x, measure angle 2 y, measure angle 3 z? I could, couldn't I? I could think of this as x, y, y, z, right? And so, what would I do to simplify this equation? Give others a chance first. What would I do to simplify that equation?
I know someone knows out there.
What if I had x plus 3 equals 3 plus z? What would I do to simplify that equation? Minus 3 from both sides. I don't have that though. I have this other up here. So what can I do to minus y from both sides, right? Well, the reality is I don't really even have those y's. So what am I gonna do now?
Take away 2.
Measure of angle 2. I'm gonna subtract that from both sides, right? So if I subtract, I'm gonna actually show this here. Measure of angle 2 from both sides. What do I get left on this side? Measure of angle 1 equals measure of angle 3. What did I use to get rid of that measure of angle 2? Subtraction property. Nice. And we didn't really say it here, but this is what we were trying to prove. Measure of angle 1 is equal to measure of angle 3. Because if I go back up here and look at the supplements theorem, it says if two angles, 1 and 3, are supplements to the same angle, angle 2, then angles 1 and 3 must be congruent. And that's how we would write that proof. Not a lot of steps to it. Nothing too alarming. Properties we learned yesterday. Okay? And we'll go from there. Again, I don't expect that you'd be able to write that proof on your own yet. But eventually, we're going to write some proofs like this, and I would expect when we get to that, that you'll be able to do it. Yeah,
Can
Hunter?
it be extra credit on the test?
No, I won't. I'm not going to put extra credit questions on a test that I think only 1 or 2 people could get right.
Oh.
If I put extra credit questions on a test or something that I would expect everybody would be mathematically ready to answer. Okay? I don't typically write extra credit questions. I typically just put extra questions on the test, so there's more points than 100 available. Okay?
Okay.
This, I think, is the last page of, yeah, it is, because we're not doing that last one. This is the last page. Let's copy these down. Congruent complements theorem, and a couple other theorems here. Let's slide this down so you get the rest of it. Hang on here. Congruent complements, just like the supplements. If I have two angles that are congruent to the same angle. I'm sorry, if I have two angles that are complements to the same angle, then they're congruent to each other. So if I know that this angle and this angle are complementary, well, that's not true. Let's say I know that these two angles are complementary, and these two angles are complementary, then that means these two angles have to be equal to each other. If this angle were, say, 60, and this is 30, that'd make these two complementary, right? Well, if this is 60 and this one's complementary to it, that would make it 30. 60 and 30 are complementary. So these two have to be equal. They have to be 30 degrees. Okay? So that's what that's saying. This next one here, all right angles are congruent. Yeah, I know that seems like a no-brainer. But there's times when we actually have to use that statement. And probably in about 100 pages of book work, we will say, hey, remember back on page 99, I gave you this simple, straightforward statement that says all right angles are congruent. Well, now we have to use that, okay? And remember, we have to give justification for everything we do. If we say two right angles are equal to each other, we have to be able to say why we know that, and this theorem allows us to do that. These names, Theorem 2.24, Theorem 2.5, there's nothing special about them. Don't refer to them as Theorem 2.4 and Theorem 2.5. The names simply mean this is the fourth and the fifth theorem given to you in chapter 2. That's all that name means. And in a different textbook, they're not going to be given to you like that. So those are not standard names, okay? In situations like this where they don't have a name, you just have to say what it says. Right angles are congruent. Two angles are congruent and supplementary, then they are right angles. Supplementary means they add up to 180, right? So if two angles are congruent and they add up to 180, that means two angles with the same measure add up to 180, they both have to be 90 degrees, right? So they have to be right angled. Okay? Alright. So as I just said, this is not homework. I'm just telling you what tomorrow's assignment is going to be today. Some of you have a lot to do at home, some of you don't. And if you want to get started on it so you have more class time tomorrow to work on your review that I'll give you tomorrow, then you're welcome to do that. So this is your assignment. Remember, tomorrow work all class periods.